Hi, welcome children. Welcome. Hearty welcome to another chemistry class. In this class, we are discussing the chapter Surface Chemistry. Some important questions from the chapter Surface Chemistry. Can we start? Ready? Yes. Here we have the first question. Coagulation values in millimole per liter of electrolytes used for coagulation of arsenious sulfide are given. NaCl 52, barium chloride 0.69, magnesium sulfate 0.22. The point is correct order of their coagulating power. That is the point. So what is the relationship between coagulating value and coagulating power? You know coagulating value so defined as the minimum quantity in millimole per liter of a coagulating electrolyte which can cause the coagulation, flocculation within 2 hours. You have learned that. So the point is that higher the coagulating value, lower the coagulating power. The concerned area in the NCERT, you might have read the last sentence of the concerned paragraph. Higher the coagulating value, lower the coagulating power. So which is having minimum coagulating power, no doubt, NaCl. According to Hardy-Schulz rule also you know that. So NaCl minimum. So 1 minimum. And thereby you get your answer. 1 minimum, and thereby you get your answer. 1 minimum only in one choice, and then it will be 2, and the maximum coagulating power will be 3, and hence the answer is option 1. Simple, direct question based on the flocculation power, flocculation value. Next question. Measuring zeta potential is useful in determining which property of colloidal solution? Solubility, stability of the colloidal particles, size of the colloidal particles, viscosity. No doubt, the charge on colloidal system is the fundamental reason for stabilizing the salt. There are certain fundamental points which causes the stability of colloids. Number 1, charge. Number 2, Brownian motion, etc. So there are several factors which stabilizes the colloidal system. One major factor is charge, and it is related to charge you are learning the zeta potential, the so-called electrokinetic potential, the potential difference maintained between the Gibbs double layer, Helmholtz double layer, right? So the point is, no doubt, second choice, it is pertaining to stability of the colloidal particles. Greater the zeta potential, more will be the stability of colloidal particles. Greater the zeta potential, more will be the stability of colloidal particles, as there will be a balance between the repulsive interactions between the charges of electrical double layer and attractive van der Waals interaction between the molecules. Right? Next question. On adding 0.025 gram of starch solution to 100 ml of gold solution, coagulation by the addition of 1 ml 10% NaCl was just prevented. Gold number of starch is. What is the definition of gold number? Learned in the classes, taught in the classes. It is the weight in milligram of protective colloid. The weight in milligram of protective colloid which can prevent the coagulation of 10 ml standard gold salt containing 1 ml 10% NaCl in it. So it is 10 ml standard gold salt. It is 1 ml 10% NaCl and the weight in milligram of starch solution. Weight in milligram of starch, that is called the gold number. Now it is given in grams. So 0.025 gram means into 1000, that is 25. There is no suitable choice present. It is 25. Yes, it is option A. Maybe it is wrongly printed. It is 25. That is the correct answer. 25. That is the correct answer. So option A is intended answer and the answer has to be 25. 0.025 gram. So what is the quantity in milligram? In 2000, 25 milligram. That is the gold number of starch. Once again, gold number related to protective action. How? Higher the gold number, lower the protective action. An excellent protective colloid will have a low gold number. Okay, next. Some gels like gelatin on shaking lose their gel structure and change it to salt. On standing, this salt again converted to semi-solid gel. You might have heard about, I believe, the salt gel interconversion. A salt gel interconversion called thixotropy. You have learned. Salt gel interconversion called thixotropy. Option D is the correct answer. What is syneresis? Syneresis means water expelled from the gel. A gel becoming dry. That is called syneresis. Water is expelled from the gel or extracted from a gel. That is syneresis. Imbibition. Imbibition. You might have learned in the biology, might have heard about in the biology classes. Imbibition. Type of diffusion where water is absorbed. Water is absorbed is called imbibition. Water expelled is called imbibition or imbibing, imbibition. Syneresis, weeping. Right? Here we are talking about salt gel interconversion. A salt converted to gel, gel converted to salt gel interconversion, we call it as thixotropy. Thixotropy. Next. Which of the following can protect gold salt from coagulating by KCl solution? See, gold salt is a lyophobic salt and lyophobic salts are protected by lyophilic salts. Who is lyophilic in the choice? Option A is lyophobic. Option B is an electrolyte. Option C, urea. It's a true solution. And the answer is option D, gelatin, which is a lyophilic salt. And a lyophilic salt can be used to protect a lyophobic salt. Answer is option D, gelatin. Next, flocculation value expressed as millimole per liter. Option D. In the first question it was commented, flocculation value is the minimum quantity in millimole per liter of coagulating electrolyte which can cause the coagulation within 2 hours. It is millimole per liter. Which of the following is least efficient? Least efficient in the coagulation of positively charged salt. A positively charged colloid, a positively ferric hydroxide is positively charged salt. A positively charged colloid is flocculated by a negative electrolyte, negative ion. A negative ion. All are given negative ion only, and that depends on the Hardy-Schulz rule. Explained by Hardy-Schulz rule. What is Hardy-Schulz rule? Greater the valence of the coagulating ion, greater the coagulating power. So a positive salt coagulated by a negative ion and the charge is maximum here, and this has got the maximum coagulating power. Our point is least efficient, minimum coagulating power, no doubt option A, having monovalent character. After A it will be B, then it will be C, then it will be D. So the efficiency comes out to be A, B, C, D. D is most efficient, will have a minimum coagulating value. A is least efficient, will have a high coagulating value relatively. Okay, next. In the preparation of AgI salt, the excess of AgNO3 is added to potassium iodide solution. Particles of the salt will acquire. Particles of the salt will acquire positive charge. Option B, or to be precisely option D, positive charge due to the adsorption of Ag plus ions. Ag plus ions. You see how the reaction can be understood? We are taking potassium iodide in a test tube. Just imagine. Just imagine we are taking potassium iodide and or we can understand in a different way. Imagine we are taking excess of AgNO3. Imagine we are taking excess of AgNO3. It is commented excess of AgNO3 and you are adding drops of Ki. Drops of Ki you are adding. Now Ki will interact with the AgNO3 and you will get a salt produced inside the system. There will be salt produced and the salt formed is AgI. Salt formed is AgI. How do you get AgI? Ki interact with the Ag, you get AgI. But the point is, this is taken in excess. That means there are excess Ag plus. So what will happen? Around the surface of AgI, Ag plus, which is a common electrolyte, common ion, will be adhering. And hence it acquires a positive charge. So if you take excess AgNO3 and drops of Ki, you will get positively charged salt. If you take excess of Ki and limited quantity of AgNO3, just imagine you are doing the other way. Just imagine you are taking excess of Ki and you are adding drops of AgNO3. What will happen? AgNO3, Ag react with I and you are getting the salt produced here. You are getting AgI once again. But here, this is excess. So, I minus the common ion will be adhering to the surface. And hence, the colloidal system turn negatively charged. So, according to which component is available in excess, either the salt turn positively charged or the salt turn negatively charged. Is it clear? So, here it is. Option B is correct. More correct is option D. Next. One gram activated charcoal has a surface area 1000 meter square. If complete surface area is assumed, how much ammonia in milliliter at STP could be absorbed on the surface of 25 gram charcoal if diameter of ammonia molecule is 3 angstrom? So you can find out 1 gram charcoal having 1000 meter square. 1 gram charcoal, 1000 meter square. Imagine it is powdered form. So what about 25 gram charcoal? 25,000 meter square. Okay. What is the area covered by one ammonia molecule? You can find out. What is the area covered by one ammonia molecule? You can find out as the diameter of ammonia molecule is given. So once the diameter is given, you can assume the radius. You can get the radius and thereby you can find out the area covered by one ammonia molecule. You can find out the area covered by one ammonia molecule pi r square as the diameter is given. Right? Now assume 25,000 meter square covered by ammonia, area covered by one ammonia molecule you got. So how many ammonia molecule total coverage in the 25,000 meter square? You can find out. Once you get number of ammonia molecule, you can find the number of moles of ammonia. Once you get number of moles of ammonia, you can find ammonia is a gas. You can find what volume at STP. I think it is clear. So 1 gram charcoal, 1000 meter square, 25 gram charcoal, 25,000 meter square. That is the total area coverage. What is the area covered by one ammonia molecule? You can find out pi r square. Right? So what is the total number of ammonia molecule? How much volume of ammonia gas at STP you can find. Let's see. See that total surface area of 25 gram charcoal, it is 25,000 meter square. Radius of ammonia molecule 1.5 Armstrong. So what is the cross sectional area? Area covered by ammonia pi r square. Okay. So number of molecules will be total surface area divided by area covered by one ammonia molecule. So you are getting this much of molecules. You get the number of molecules of ammonia. Once you get number of moles of ammonia, you can find the number of moles. Number of moles is equal to number of particles divided by Avogadro constant. You get the number of moles. Once you get a number of moles, you can get the volume at STP. How it is? 1 mole 22,400 ml. 1 mole 22,400 ml. 0.589 mole. 0.589 into 22,400 ml at STP, which will come around 13210 milliliters. 13210 milliliters, option C as the correct answer. So total area covered, we know. Area covered by one ammonia molecule, we can find. Therefore, total number of molecules, we can find. Therefore, what is the volume at STP? We can calculate. Clear? Workout. Workout. Similar questions came many times. Okay, next. Viscosity of lyophilic salts. Lyophilic salts are more solvated. Lyophilic salts are more solvated, and all of you know viscosity will be slightly higher than that of dispersion medium. It is higher than that of dispersion medium, no doubt about it. While lyophobic colloids will have almost the same viscosity as that of the solvent. So lyophilic salts, due to greater extent of solvation and the interaction, there seems to be generally higher viscosity than dispersion medium, while lyophobic colloids will be almost the same as that of the medium. Aquadag. Aquadag is graphite in water. Graphite salt prepared in water is called aquadag. Graphite salt prepared in oil is called oil dag. Aquadag, oil dag. Next. Freshly prepared ferric hydroxide can be changed into colloidal state by treatment with a solution of peptization. Peptization. Freshly prepared ferric hydroxide made to powdered form, added to solvent, and add a small amount of ferric chloride, which will stabilize the salt, and the process called peptization. Learned. Peptization. The diameter of disperser, the size of colloidal particle, fundamental question. 1 to 1000 nanometer, 1 to 1000 nanometer, that is the size range of colloidal particles, option B. Which is strongly absorbed by charcoal? Which is strongly absorbed by charcoal? Ammonia, an easily liquefiable gas, will have a high molecular attraction, and that will be absorbed easily. Among the list, ammonia is easily liquefiable gas, while hydrogen is tough to liquefy gas. So strongly absorbed ammonia, weakly absorbed hydrogen. Right? Next. Which is true about chemisorption? It is highly specific. That is true. Chemisorption is highly specific. Chemisorption is irreversible. Chemisorption increases with increase in temperature. At a low pressure, physisorption is favored. At a high pressure, at a low temperature, physisorption is favored, while chemisorption favored at high temperature. As the temperature increases, adsorption increases, and hence it is called activated adsorption. As the temperature increases, the molecules getting more activated and more adhering to the surface in terms of chemisorption, as it is an actual chemical bond. And hence it is called activated adsorption. It involves van der Waals forces, wrong. It involves chemical bond. Answer is option A, highly specific. It is highly specific. An example of emulsion is, milk. Milk is the emulsion. Typical example for emulsion is milk. Liquid in liquid salt. Liquid in liquid salt. While the other category, all of you know. Movement of colloidal particles under the influence of applied electric field is called electrophoresis. Migration of colloidal particles under the influence of electric field, that is called electrophoresis, cataphoresis, which is a clear evidence for the charge of colloidal particles. According to Freundlich adsorption isotherm, which of the following is correct? Option C, x by m is equal to Kp raised to 1 by n. X by m is equal to Kp raised to 1 by n, where x is the amount of adsorbate, m is the amount of adsorbent, K is a constant, and P is the pressure, and the power of P will be lying between 1 and 0. The power of P lying between 1 and 0, that is what? 1 by n. Suppose n equal to 1, 1 by 1, 1. Suppose n is a large value, 1 by n, 1 by a large value, 10 to 0, like that. So at a low pressure, x by m proportional to P. Hope you remember the way the derivation of this happened. At a low pressure, x by m proportional to P raised to 1. At a high pressure saturation condition, x by m proportional to P raised to 0. That means constant. And to demonstrate the value of between power coming between 1 and 0, we write 1 by n. That is Freundlich adsorption isotherm mathematical formula. Next. Micelles are formed by surfactants above CMC. Micelles are formed by surfactants above CMC. Correct. CMC means critical micelle concentration. The concentration above which micelle formation takes place. Below which it acts as a true solution. Above which it acts as a micelle. The conductivity of solution having surfactant molecules decreases sharply at CMC. Right? Because below CMC, it will act as a true solution. Below CMC, it acts as a true solution, and above CMC, it acts as a colloidal matter, and the conductivity decreases sharply below CMC. The conductivity decreases sharply below CMC. So we can have a graph like this, am I right? Just imagine lambda conductance versus concentration. It may come like this. It may come like this. There can be a sharp decrease like this. The conductance decreases. At this point, this is CMC. This is CMC. Above CMC, there will be a sharp decrease in the electrical conductance because a true solution, which is an electrolyte, converted to colloidal system. Right? So both are supporting statement. Option A, if S is correct, E is wrong. B, C. We will take option C. We will take option C. There is no supporting statement given. It is option C. Statement S and not E. S and A. S and A are correct. Both the statements are correct, and probably I would say it is a supporting statement also. Next. Yellow colored arsenic sulfide salt is mixing with a red colored ferric hydroxide salt giving colorless solution. Yes, it's a true statement. It's a true statement because it undergo mutual coagulation. Arsenic sulfide is a negative salt. Ferric hydroxide is a positive salt. There will be mutual coagulation and the color will be lost. The negatively charged arsenic salt is neutralized by positive salt, result in that. Yes, exactly. Exactly. Both are true statements and the correct explanation also. Both are true statement and the correct explanation also. We will go for once again option C. Both are true and correct explanation also. Okay, next question. Not a surfactant. Not a surfactant. This is a surfactant, a cationic detergent. This is not a surfactant. Option B is the answer. That is not a surfactant. This is an anionic detergent. This is an anionic detergent. So all these are surfactants except B. B is not a surfactant. It's a simple amine. A surfactant or a soap molecule, detergent, you know it will have a hydrophobic tail and a polar head like this. It will have a hydrophobic plus or minus. It will have a non-polar tail. There will be a non-polar tail and there will be a polar head. All of you know. There will be a non-polar tail and a polar head, which is there in, this is non-polar tail and there is a polar head. This is a non-polar tail and a polar head, non-polar tail and a polar head, and such a scenario not available in option B, and that is the answer. Next question. Which is not a lyophilic salt? Which is not a lyophilic salt? See, organic salts, natural salts are lyophilic in nature. Starch, typical example. So they are all lyophilic salt, while usually inorganic salts are lyophobic salt. Here option C is a typical inorganic salt and that is expected to be lyophobic, while milk, gum, blood, they are all natural organic salts. They are expected to be lyophilic. Okay. Next. Temperature above which micelle formation occurs called Kraft temperature. Kraft temperature. The temperature above which micelle formation occurs. That is called Kraft temperature. Next. Quaternion precipitator is used to electrostatic precipitator, quaternion precipitator, smoke precipitator. Option A, yes, true statement. Option B, true statement. Option C, true statement. Answer is option D. All are true statements only. Okay, next. Purple of Cassius. Purple of Cassius is gold salt. Gold salt is called purple of Cassius. Silver salt is called argyrol. So some of the common names, you keep it in mind. Purple of Cassius, that is gold salt. used in many of the medical industries. Gelatin used in ice cream manufacture. The reason is to prevent the formation of colloidal, wrong. To prevent the crystal growth and stabilize the colloid. Option B is the correct answer. It is used as a protective colloid. Gelatin used as a protective colloid. So that when you prepare ice cream, think how much time back the ice cream which you are purchasing from the shop is actually manufactured in the factory. Whatever brand it is, they all having a common procedure of preparing the common cream. It is manufactured in a common standards. And simply what changes is the flavors and their additives. That makes the difference in the brand. Otherwise, it is all common. And when they manufacture cream, how much time, weeks or months, without any problem, it is stabilizing, available as a ice cream, which never happens when you prepare at your home because of the special additives that are given there to stabilize the colloidal system. Isn't it? So that is the point. Option B. The plot for the adsorption isobar for chemisorption in the following is chemisorption. This is physisorption. This is physisorption, option A, while option C is our answer, chemisorption. And see, the graph has to be somewhat like this only. Graph has to be somewhat like this. X by M versus temperature. It's coming like this. And is activated adsorption. And there will be a saturation. Upon high temperature, of course, it will come down. But immediate down, that is not expected. Immediately coming to down. Anyway, no other choices. No other choices. It will increase and reach maximum. And upon high temperature, it may fall down also because the bonds formed may break also. Okay. Anyway, it is an activated adsorption. It is an activated adsorption and increases with the increase in temperature. Okay, next. Which equation represents Freundlich's adsorption isotherm? That already we have seen. This is the expression. Oh, okay. Not only that. This is correct. This is correct. This is correct. At a low pressure, already I told you, at a low pressure, X by M proportional to P raised to 1. You see that? X by M proportional to P raised to 1. Now, upon taking log of this, you will get this. Answer is all the above. All are true statement. So, log X by M is equal to log K plus 1 by N log P. So, plotting a graph, log X by M versus log P, you get a straight line graph with a positive slope and non-zero y-intercept. Non-zero positive y-intercept. Okay, next. On adding few drops of dilute HCl or FeCl3 to freshly prepared ferric hydroxide, red colored colloidal solution is obtained. The phenomenon is called peptization. This is what called peptization, preparation of colloids. Dispersion method of preparation of colloid, peptization. Option A. A catalyst in the finely divided form is most effective because less surface area available, wrong. More active centers are formed. That is the correct answer. More active centers are formed. In the powdered form, there will be greater surface area, there will be more active centers, and there will be more adsorption, and that will enhance the catalytic activity. That's why many times we use catalyst in the powdered form. Okay? And that was the last question from the chapter. Yet another simple chapter concerned to more onto the theoretical aspects and a very few problem type questions only. A simple chapter from the entire plus 1 plus 2 syllabus of NCERT standard. A chapter which you can learn very easily of your own itself. Okay, we will meet with another chapter, another important question, set of questions in the next class. Okay, till then, take care. Bye. See you.